The whole point of learning derivatives is so that we can solve some problems. So we're going to look at some basic applications. Find the points on the line y equals square root x minus 3, where the slope of the tangent is parallel to the line x minus 4, y equals 1. It'd be awfully nice if we had a picture. So the root of x minus 3 is a square root graph that crosses at 3. X minus 4, y equals 11 with an x-intercept of 11 and a y-intercept of negative 11 over 4. So we're finding a point on this line where it's got the same slope. So somewhere up here, we're going to have a line with the same slope as the blue line. So we want these beautiful straight lines to be parallel. Okay, so same slope. Slope means derivative. Okay, so we'll take the two functions and we'll take their derivatives. X minus 3 square root is x minus 3 to the 1/2. That's a chain rule. Bring the half down, leave the bracket alone, lower the power by 1. Derivative of what's inside is just 1, so I didn't bother writing it. And then exponent of negative 1/2 means we can write it in the bottom as a square root. So I hope you're getting really quite good at your derivatives because you're going to need to be. So again, what we did, we used a chain rule on this, took the derivative, which gave us a to the 1/2. Derivative is a to 1/2, a to the negative 1/2. Derivative of what's inside. We're going to take the derivative of this side as well. We're not used to seeing y on this side, so let's get it to the other one. Divide both sides by 4. And then I would recommend writing them as separate fractions. And I'd even recommend writing it this way. So what did we do? We brought the 4 over, divided everything by 4, split them up into separate fractions, and then wrote it this way. So why am I allowed to do that? X over 4 is the same thing as x over 1 times 1 over 4. And why would we do that? I'm hoping that you'll see that the derivative is just 1 over 4. So what did we want? Parallel lines. Parallel lines have the same slope. So this slope and this slope need to be the same, meaning we're going to make them equal to each other. All right, so they're the same. How do we solve that? Well, if we multiply and divide our denominators, we've got a 4 on the bottom. We've got a root x minus 3 in the bottom. We have a 2 in the bottom as well, but that 4 will take care of it. So our goal is to simplify our denominator. And if you've done it right, all your denominators are gone. So what are we left with? 2 on this side and root x minus 3. All right. How do you solve a radical equation? You do that by squaring both sides. So that would give us 4 equals x minus 3. And so what does x equal? So x equals 7. And often we get to this point and completely forget what the question was. So here was the question again. Find the points on this line where the slope of the tangent is parallel. And we're saying it happens at 7. So at 7, when you draw the tangent line, it's going to be parallel to this blue line. Yeah, we could believe that. And the point on the line, a point on a line is an xy. The only thing we know right now is 7. So we're going to need to find out what y is. So y would equal the square root of 7 minus 3. And that equals the square root of 4. And the square root of 4 is 2. Okay, so now we have a point on the line. The S just means maybe there's more than one. But I don't think you can draw any other tangents that are going to be parallel to that blue line. They're all slightly different. It's only that one that matches. Okay. Let's do another one. Find equation of the tangent to y equals x squared at 3, 9. And again, I'm going to draw a picture. Y equals x squared is a parabola. 3, 9 is a point on the graph. Tangent is here. So equation of the blue line, that looks like a straight line to me. So the equation of a straight line is y equals mx plus b. M stands for slope. We find the slope by finding the derivative. Okay, so we'll find the derivative. Now we're finding the derivative right here, which is at the 0.39. So it looks like we can put the 3 in. So the slope of the tangent is 6. Okay, how does that help? We were finding the slope, right? So now we know this much. If we only knew what b was, we'd be done, because that would be the equation of the line. What else can we do? We know we've got the 0.39. 39 is an xy value on this line. What if we put 3 in for x and 9 in for y? Would that help us find out what b was? We've got 18 over here. Pull the 18 over. So we now know that b is -9. So our first guess at the equation was 6x plus b, but now we know that b is -9. So our final answer, 6x minus 9. Should we do that again? Equation of the tangent. We drew a parabola. These are tangent lines. Tangent lines are lines that just touch the graph but don't go into it. And we were finding the tangent at the 0.39, so it's the blue line. Equation of a straight line, y equals mx plus b. M is slope. Derivative is slope. So we found the derivative. Plugged in the point, found the slope. This was our first guess at the equation. We just needed to find b, and we did that by working with this xy value, putting 3 in for x and 9 in for y. Once we knew what b was, we had an equation. Let's do a different one. Determine the points where a cubic has a horizontal tangent. Now, this is a very accurate graph. You could have just gone, I have some kind of cubic. Doesn't really matter. Horizontal tangent is where the tangent line, the slope is equal to 0. So these are points with horizontal tangents. So we're looking for 2 of them. What we said again, slope or derivative equals 0. All right, so we'll find the derivative. So there's our function, there's our derivative. Let it equal 0, and we solve it. Okay, these numbers are really quite big. I wonder if we could divide by 6. That looks easier. And then we're going to factor it. So 2x squared, 2x times x, 2 times 1. Does that give us 5x? There's 2x and 4x. There's our 5x. So what would x equal? I'm getting a half or 2. And does that make any sense? Oh, it does, doesn't it? Look at that. Yeah, that looks like that's at x is a half. And 2, definitely. Okay, so we found out the x values where the slope is 0. Is that what we wanted? Find the points. Wait, points are x, y values. What else do we need to do? We're going to have to take our x value and plug it in. All right, let's work these out, shall we? So when x is 2, we get 4 times 8, 15 times 4, 12 times 2. Okay, so 32 minus 60, 24 minus 3. So I'm getting 57 minus 6 is minus 3 minus another 3. Wait, I did something wrong. 56 minus 60 is minus 4. Minus 4 minus 3 is minus 7. So that first point was 2, -7. And does that look, oh yeah, look at that. We can even check it with our perfect graph. Now, when you do it, because your graph is just going to be a rough sketch so you know what's going on, it's going to be a little bit harder to know exactly where that is. But again, you'd say that's 2 and -7, and that's where the slope of the tangent is equal to 0. I think we have another one to find. At a half, this is going to be a little bit more challenging. Put in a half. A half cubed is 1 over 8. A half squared, 1 over 4. A half of 12 would just be 6. We can reduce those and just get a half. And we can combine these and just get 3. I think I'd look for common denominators now. Put everything over 4. Multiply that by 2 and that by 2. Multiply this one by 4 and by 4. Now that we have a common denominator, 2 minus 15 plus 12. So 14 minus 15, I've got -1/4. And does that look like it makes sense? It does, doesn't it? Huh. And again, when you're drawing yours, you draw something like that. You'd have a pretty good idea that this value, the -7, is very likely below this value of 1/2 and -1/4. So because we knew this was a cubic positive, starts in bottom left, ends in top right, we would have expected this point to be higher than this point. So the math would all be looking good, even though you don't have quite as accurate a graph as I do. So there's our point and your job today. These are just your basic applications. You're doing lesson 5, question 1 to 10. What you're going to find with these questions is the derivatives are so much easier. So you worked really hard on derivatives, and these will be much simpler to work on. So you should really like this section. All right, go and have some fun.